On May 1, 2024, a seemingly ordinary sunspot appeared on the eastern edge of the sun. At first, it was nothing unusual, just one of the many sunspots that come and go. But as the days passed, this sunspot grew at an astonishing rate, swelling to a size 17 times larger than Earth itself. Scientists labeled it active region 3664, and it didn't take long to live up to its name. This colossal sunspot unleashed fierce solar flares, some so powerful they triggered coronal mass ejections aimed straight at Earth. The result, one of the most dazzling aurora displays in recorded history, with vibrant lights stretching across the globe to places that had never seen them before. According to NASA, this was the most powerful geomagnetic storm in 500 years, and it even rattled observatories deep underground. The sun didn't settle down after the intense solar storms in May. Instead, it continued to unleash bursts of M and mild X-class flares, keeping space weather experts on high alert. Then, on October 3rd, it released an enormous X9.0 flare, the strongest seen in 7 years, right from the center of its disk. Within a week, a powerful G4 geomagnetic storm hit Earth, lighting up the skies with vibrant auroras in places unaccustomed to such displays and disrupting radio communications in some parts of the world. All of this pointed to one thing: the approach of solar maximum. Now NASA has officially confirmed it. The sun's magnetic field has flipped, and the solar maximum has arrived. So, what will the solar maximum do to our planet in the coming months? How long will this period of heightened solar activity last? Finally, and most importantly, will this increase the average global temperature and warm our planet over the next year? The sun may look like a bright, constant ball of light, but it's far from steady. Every 11 years or so, it goes through a dramatic transformation known as the solar cycle. This cycle, which impacts our planet in many ways, involves changes in the sun's activity, magnetism, and even appearance. The discovery of the solar cycle dates back to the late 1700s when astronomers noticed something strange while observing sunspots, dark patches on the sun's surface. Astronomers realized they didn't appear randomly. Instead, the number of sunspots grew and shrank in a pattern over time. The observations revealed that sunspots increased and decreased in number every 11 years, a cycle that scientists would eventually call the solar cycle. Following this discovery, astronomers started paying close attention to this phenomenon. For a long time, they kept a record of solar activity by observing the behavior of sunspots alone. But as technology improved, they noticed two more things that changed over a solar cycle. The first was the solar magnetic field. Our sun is a huge ball of charged gas or plasma, and its magnetic field is constantly changing. Astronomers found that the magnetic field goes through a complete reversal of polarity with each solar cycle. This means that the solar magnetic north becomes south, and the south becomes north. The pole reversal happens around a solar maximum, marking a cycle's midpoint. Another aspect of the sun that changes with the solar cycle is its overall activity, including solar wind, flares, and coronal mass ejections. This activity reaches its highest point at the solar maximum and its lowest at the solar minimum. Because of these findings, monitoring solar cycles now involves looking at solar activity and polarity reversal in addition to counting sunspots. Since the initial discovery of the solar cycles, astronomers have tracked each cycle and assigned them numbers. We're currently in solar cycle 25, but each of the preceding 24 cycles had unique characteristics. While most followed the expected pattern of rising to a maximum with many sunspots and then declining into a quiet minimum, there were two strange periods in history that we still can't explain. Just as we observe each solar cycle with awe, wondering what mysteries lie in its rise and fall, Moog Globes lets you bring that same wonder of awe right on your deck. Powered by ambient light and hidden magnets, they spin silently, creating a serene and mesmerizing display in your home or workplace. No cords, no batteries, just a charming display of science on your desk. Moog Globes comes in over 40 captivating designs, including an outer space collection that features planets, moons, asteroids, and constellations. It's a perfect way to keep the wonder of space within reach every day. And for viewers of this channel, I've arranged a special offer. Use the code S at mob.com to get 10% off on 6-inch and 8.5-inch Moog Globes. So check out the link in the description and bring a piece of the cosmos home. Now, back to the sun. The first unexplained span is the M minimum, a period of extremely low solar activity between 1645 and 1715. During these 70 years, sunspots became almost non-existent, with astronomers observing only about 50 sunspots over the entire period, compared to the thousands that typically appear in a single cycle. This extended solar minimum coincided with a time known as the Little Ice Age, when parts of the world experienced colder-than-average temperatures. Rivers that rarely froze, like the Thames in London, iced over, and Europe faced harsh winters. Following the M minimum, the Dalton minimum occurred from about 1790 to 1830. Although less extreme, this period also had lower-than-average solar activity. Like the M minimum, the Dalton minimum coincided with a phase of cooler global temperatures. Major volcanic eruptions during this time, like the 1815 eruption of Mount Tambora, also contributed to global cooling, creating what is known as the year without a summer in 1816, when widespread crop failures and food shortages affected Europe and North America. Solar cycle 24, which started in 2008, was particularly weak. Sunspot numbers in solar activity were well below average, marking it as one of the least active cycles in over a century. Scientists were surprised by its low intensity, as it had far fewer solar flares and coronal mass ejections than expected. This quiet cycle raised questions about what causes such variability in solar activity and whether a future grand minimum, similar to the M minimum, could occur. When the current solar cycle began in December 2019, it was predicted to be even weaker than the preceding cycle, but we were wrong. Solar cycle 25 beat all expectations. In August 2024, the average daily sunspot number likely reached 299, more than double the anticipated value. This level has not been observed in more than 20 years. A fascinating twist in the current solar cycle is that its peak arrived sooner than scientists expected. When this cycle kicked off in December 2019, forecasts aimed for a peak in July 2025 with around 5 sunspots. But by January 2024, NOAA's space weather prediction set adjusted its forecast, now expecting the peak to fall between January and October 2024, with a more intense estimate of 137 to 173 sunspots. On October 15th, NASA confirmed that the solar maximum period had officially begun. However, NASA's announcement doesn't mean this is the highest level of solar activity we'll see. While the sun has entered the solar maximum period, identifying the exact peak of activity will take time. Scientists need to track solar activity for months, possibly years, to confirm the true peak, only determined after observing a sustained decline. Notably, the past 2 years have already shown elevated activity, with frequent sunspots marking this active phase. Scientists now expect the sun to stay at its maximum phase for about another year before it begins its gradual slide back to a quieter period known as the solar minimum. This means the next few months are going to be critical, and we can expect severe geomagnetic storms and spectacular auroral displays. Many powerful solar storms in recorded history have left a lasting impact on Earth. The Carrington event is the most famous and intense solar storm on record. It occurred on September 1st and 2nd, 1859, when British astronomer Richard Carrington observed a massive solar flare. Just hours later, a coronal mass ejection slammed into Earth, unleashing an intense geomagnetic storm. Telegraph systems across Europe and North America went haywire. Some telegraph operators reported receiving electric shocks, while others observed that their machines worked even with the batteries disconnected. Powered